This is a presentation on the new features within Alphacam to the ability to add a scratch cut in a cut. Worry of now to cut the disc and in the disc will then slice, and we've also added the ability for support of cans now available for the machine. 2016 did material suitable. We'll go in your general tab here, and I'm going to select the geometries that I past the open ends vertical. If we look at the levels of cuts now, I'm going to enter my file, add a scratch cut. I can make it opposite 1 millimeter, and I can make it the same direction as the first cut, or I can make it opposite. Here we obviously see the option to add linear code or can cycle if this machining is suitable. The machining data I can add stock if I require, and we have the tooling data relating to the tool. So I'm happy with this. I'll click OK, and now I can add my tool path. If we now go into the solid simulation, we'll get to see our laminated material, and we'll watch the scratch cut go and just cut through the top of the laminate, and then we'll see the tool path return to cut through to the depth as required. This shows us how we have our scratch cut. The part I now have on screen consists of an internal arc, and I'm going to want to cut this using my disc tool. So let's go and select the tool and go into our sawing command. I'm going to work with auto Z levels this time, and I'm going to now select internal arcs. If we now go to the General tab, we can see this has changed the items that I have for selection. It's only going to be machining open ends, so we'll select a cut pass by 10 again. Regarding the amount of tilt required on the disc, we can select automatic, which means the system will automatically detect, due to the size of the tool and the size of the feature we're cutting, the optimum angle for tilting. You can adjust this by an extra value if required. Or you can pick a specified angle and type in the angle that you want to work to. I'm going to go with automatic in this instance. Regarding the levels, I'm going to obviously go to my Z level, but I'm going to go a couple of millimeters past, and let's do this in a series of cuts. I'm not going to want a scratch cut on this one, and regarding the machining data, no stock required, but I will add a lead in lead out. We'll notice a bit of a difference here as we apply the lead in lead out, that we're actually giving a 3D lead in lead out. That's because this type of toolpath will be applied as a 5-axis toolpath. I'm just going to enter in the values that I require here. And say OK to that, and then we'll pick our arc. And we can now see that we've got our machining, and if I just run a simulation on this, we can see we have the disc and it's tilted over accordingly. I'm now going to go into the solid simulation, so prior to doing that I'm just going to open up a machine configuration, just a simple one this time of a head-based scenario, and we're going to now go into the simulator. Now in the simulator we can click play and watch the machining of the internal arc. So this now shows how the system can cut these arcs for us. Cuts we've been looking at before were basically just one type of cut down the profile. The tool. Select a tool. Our disc is 3.2 millimeters wide. If we go into sawing, we're now going to pick to cut a shape. Looking on the General tab, we can obviously decide whether we're going to be left or right. For this feature, the tool will always be vertical. And Z levels, I'm going to go no scratch cut required. Machining data now to 3. And what we now get is a series of cuts to cut the feature. So if we go into the solid simulation, my slot for me, just limited to slots, 5 millimeters. I can't come in here and edit this feature. So if I go for a fillet of 5 millimeters between this feature and this feature, and then let's do something a little bit different on the other end. Let's put a chamfer. We'll go for a distance of 6 and 20. So we've got these features on here. The operation needs updating, but rather than update it, I'm going to edit it now because I've actually put some features on there to get a better definition on it. I'm going to want to have a shallower step over. If I just change that to 0.5, we're going to get many more cuts, but we'll also get a better definition on the machining. And we can see where the cuts are being staggered on this end for the chamfer, and adjusted on this end for the radius. We're also not going to get a true radius. We are cutting with a sharp tool. Obviously, you might be able to use saws that also have a radiused corner edge on them.